Please make her very, very welcome. It's Lisi Linhart.
Thank you. Hi, everyone. So, yeah, they already mentioned that I'm from Salzburg. I lecture at the university. I write about mostly front-end on my blog, and you can talk to me on Twitter if you want to, but let's get started with the web animation part. So when we build new applications, we're great at building efficient workflows and using Webpack and functional CSS, but most of the time we have a limited budget and also limited time. And a lot of people rather optimize other things than do web animation. So why is that? I think it's because a lot of people see web animation as kind of the sparkles that are on top of a project, kind of what it makes it more fun, but most of the times you don't have time to do it. But the thing is, it's really useful. It can be really useful for user experience, and I want to tell you why that is. But when we do web animation, we also have to think who we're building our application for. So animation can be really useful, for example, if you build for a younger audience where it can make everything more playful and explain different steps. Like for applications for children, animation can be really useful, but then maybe an elderly person might prefer to read some information in their own speed, and then the animation might be distracting, and maybe they don't need the animation like a younger person would maybe. So one part of web animation is the user. So who are you building the animation for? What goal does the animation have? And the second part is the browser. So the browser needs you to build your animations in a certain way so they're performant. Your animation is gonna run differently on a mobile phone where you have less performance. So you have to think about how the browser works on desktop, on mobile. Here I made a little chart because I work at a university and I should have a scientific chart. So there's the browser, there's a user, there's a lot of keywords on hard and easy. Web standards are important, so make sure you use web standards, and it's going to make it easier to build accessible applications. And then you can do different things. You can take care of browser support. You can build an animation to increase orientation in the user. You can build animations to give attention to the user. And you can optimize your animations for the render engines of your different browsers. So there's a lot of different things that come together when you do web animation. So when we animate with the browser, there are 4 things we can animate really cheaply. One is the position, so transform, translate X, for example, or translate Y, or 3D transforms. Scaling, so making objects bigger or smaller. Rotating objects, and animating the opacity, so fading in and out. This is what that looks like in CSS, so we can translate it, scale it, rotate it, and every transform looks a bit different. So scale, for example, takes a value from 0 to 1, but then rotate takes degrees. So you have to kind of learn these to use it right, and then you can chain them. And the order matters for those properties. So there's a really great pen showing that by Dan Wilson. So if you translate something first and then rotate it and then scale it and then translate it again, it will end up in a different space than if you scale it first, then rotate, then translate it. So think about those things when you use it. So let's say we want to animate a little menu. And if you wouldn't know about the transform property, what you might do is give it a left property and then add a transition on all CSS properties and then give it a class that animates this left property. And this is really unperformant because left is a layout property and it's really unperformant for the browser to animate, and I'm going to tell you why. If you want to do a menu animation in a more performant way, you would use the transform property with a translate X and then transition only the transform, not all CSS properties. But let's look at why animating left is not performant. So when we change something in the browser via JavaScript event or via CSS with, for example, a hover, we have some kind of visual change that needs to re-render something. And then the browser, after the change, needs to recalculate the new style. So something happened, you hovered something, and it needs to figure out how the element looks. And then it needs to redo layout. So for example, if you change width, margin, left, the browser has to find out how much space each element takes and how much space the other elements next to it take and how much space the elements inside of that element take. So it has to do a lot of style recalculations. If we skip that step and don't animate layout properties, we can also animate paint properties. These are properties like background, box shadow, outline. And this is more performant because we don't need to recalculate the whole layout, but it's not the most performant step. So the most performant step is the composite step. It's mostly only transform and opacity. And this is important to limit yourself to the composite step at most of the times. I mean, you can also animate paint or layout properties, but then you need to test if it's performant enough on all the devices. And all of this happens in one frame. So if you take really long on layout and recalculating, you will get less frames in the end. So by limiting yourself to this, you get more frames and it will be more performant. So limit yourself to transform and opacity will make it easier for you to create performant animations. And then if you do a lot of animation, what you can do is to promote elements on new layers if they're animated often and consistently, like a menu or some element that's consistently moving. And we can create new layers by using the will change property or 3D transforms or some kind of 3D effect. These is a list of things that create new layers. So will change, 3D, animated 2D transforms also create new layers like animations. Being on top of a compositing layer and animated CSS filters also create new layers. I built a small demo for you to demonstrate that. So here we have 3 turtles. Each turtle has their own div. And if I wouldn't know about transform, I might animate some layout property like margin. So I'm giving it a margin when I'm hovering it. And then I'm adding a transition to animate it smoothly. And now when we hover it, we see, well, the other turtles are affected as well because I'm recalculating the layout and I'm changing layout properties, and we only have one layer if we go to the layers tab. What we can also do is turn on paint flashing. This is really useful to see what needs to be repainted. So here I see if I hover one turtle, all the other turtles need to be repainted as well. And I can also turn on the FPS meter to track how many frames per second I have. So now instead of animating margin, I'd animate transform, translate Y, and then transition the transform. And now if I hover a turtle, I see, well, only this turtle is repainted. If I go to the layers tab, I see I still have only one layer. And if I hover the turtle in the middle or the first, we see the last turtle also needs to be repainted when I'm hovering that turtle because it's on top of the other turtles. So I could add a will change transform, and then I'd get a layer for each turtle. And if I hover the turtles now, there's no repainting because they don't affect each other. But if we use layers, it's important to not create too many layers because each layer takes up memory in your browser. And you don't want to take up all your browser's memory. That's why you should only create a few layers if you animate something consistently and then remove them if the animation is finished via a class, for example. And then the last part with animations is in the browsers is to really just test them. You have the performance tab. You can record some animation here with this. Then you get lots of colors here. These red bars show you that you have too little frames per second, so there's some problem here. And this summary is very useful to just get a general overview of what's happening. The paint flashing shows you what needs to be repainted, and the FPS meter shows you if you have enough frames per second. And then the layers is also useful to track your memory and see how many layers you're creating, or if you're creating actual layers you don't need via applying some CSS that creates layers. And here in the bottom with the summary tree, this tracks back to how the rendering works in the browser. So if you have lots of rendering, you're probably changing some property here that has to recalculate layout. If you have lots of scripting, your JavaScript might be expensive and you're doing calculations in JavaScript that take too long. And if you have lots of painting, maybe you shouldn't animate a paint property or you're doing too much painting. So just by looking at this, you get an idea of what might be wrong in your animations. This is the first part about the browser. Now we want to think about the user. So how can I do animations that are actually useful to the user? One useful use case is orientation and transitions. So when we have a site, we have different pages, and we can just jump from A to B, and then site A looks like this, and site B looks totally different. That's possible, but by transitioning between those two sites, we can make the information space more understandable to the user. So here's a little example of a website. They always transition from each side to another side and then slowly fade in the different elements. And by doing these subtle transitions that users often don't even notice that are there, it's more understandable what changed in this website. So animation can help to reorient the user, to show to him what changed, and it can also help to explain the relationship between the different information spaces and also between the different elements. And I have a little example in Vue.js for you, but you could also do this in React or without a framework with Barber.js, for example. And the links to the whole code is on Codeban, so you can look at these later. So this is a little application that has 2 buttons, and then I can click one button. If I click location, the animation comes in from the left. If I click date, the animation comes in from the right. This looks quite easy, but it's not too easy if you think about it, because if you click location, the animation has to come in from the left, and then it should slide out to the right. And with date, it's the other way around. So it should come in from the right and slide out to the left. So we have 2 different animations we want to apply depending on which button we're clicking on. In Vue, we simply track our view. So our view is location or date, and we save this in our state. And then our navigation takes this view state and changes it if we click one of the 2 buttons. And then in what we have in Vue to create transitions is this transitions property, and we can wrap it around components that are attached or detached. So this is only attached if the view is location, and this is only attached if the view is date. And if we have this transition component around our components, we get these different CSS classes. We get enter classes, we enter 2, we leave 2, and we can use those in CSS to create our animations. So we need this wrapper. The transition needs some kind of name, which we're going to use in CSS. And the mode out in just says, well, first transition an element out that's being detached, and then transition the new element in. So wait until the other one is gone. And then we have some default states on our objects, like that they're visible and that we want to transitions that transform. And we can also have different transition timing functions for if they're entering or if they're leaving. And then we have this enter class, which equals to this. So when it's entering, define how it should animate before it's coming in. So it should be not visible and it should be on the left. And then you define the leaving class, so it should go to the right and it should be non-visible. And then here we're using different timing functions, because when it's coming in, it should get slower towards the center, and when it's going out, it should start slowly and then get quicker towards leaving. And for doing the different animations, so for having dynamic transitions, we bind a transition state to the transition, so we can adapt in a state what transition we want to show. So if the view is state, we want to show a different transition than if it is something else. And that makes it possible to have different dynamic transition depending on what's happening in your application. The next good use case is perceived performance. There's a really great quote by Chris Harrison that says, human perception of time is fluid and can be manipulated in purposeful and productive ways. It's from a paper called Faster Progress Bars. And what they found in this paper is that by animating the progress bars, the perceived duration of the loading experience was reduced by 11%. So just by using animations, the people who viewed this animation thought there was less time passing, which is good. To give some more information on this, there's a really good book called Usability Engineering, and it has some information on how timing feels to the user. So 0.1 seconds feels instantaneous to a user. With 1 second delay, the user will feel the pause, and with 5 to 10 seconds, it will be hard to maintain the user's attention, and he might just leave because it's taking too long. So we can use animation to show that something is loading, to give some indication of how the progress is going in your application when he's waiting or she's waiting. We can help with lazy loading and hinting. For example, by showing a skeleton screen of what content is being loading, like YouTube or Facebook are doing. And we can use idle times to inform the user. This is really useful when you're having some kind of process, like a booking or something, and you have to load and process something on the server. And then you can give some information on how it's going on and what's happening next, so the user can use this idle time for something useful. The example for perceived performance is a little loading example I built, but first I will explain how the Web Animation API works. So the Web Animations API is a fairly new API we can use in JavaScript to do animations. And we do it by getting an element and then calling the .animate function on any DOM element. And then the .animate function takes 2 arguments. The first one is the keyframes object or array, and the second one is a timings object of how the animation should run, how fast it is, how much delay it should have. For the keyframes, we can either have an object with the different CSS properties, and then these are the different stages. So this would be 0% and this would be 100%. Or we could have an array, and then each object is 1 keyframe. So at 0%, I have no opacity in this color, and at 100%, I have opacity 1 and another color. And then the timings object takes all the additional information of the animation timing. So like the duration, that it takes 2 seconds, how often it should run, the iterations, the direction. And if you look at this and have done CSS animations before, it looks really familiar because it's using a lot of the rendering how CSS animations work. So this is a CSS animation, like we already know, that has some keyframes at 80% and 100%, and then we call the animation with the animation keyword. And if we want to do the same animation in the Web Animation API, we'd get the element, we'd call the .animate function, and then we'd have the different keyframes. And this 80% and 100% translates to the offset in the keyframes. So the offset can be from 0 to 1, and then 0.8 would be 80% in the animation. And then we have the timing separately from the keyframes, and that has the same keywords like alternate and ease in, ease out, and iterations. It's kind of the same as the CSS animation. So the example I built is a little loader of the Pixel Pioneers logo. And there's 3 different parts we're animating. So we're animating the text, we're animating the watch, and we're animating the needle of the compass. So for the text, we have a clipping mask that we're animating with transform scale, because transform is very performant. Then for the watch, we're animating the opacity for the compass. And for the needle, we're animating opacity and the transform to make it rotate. So what does the markup look like? It's a SVG I got from the website. And we need a clip path on our text to animate. So we define a clip path. And the clip path has the width and the height of the view box. So it's just as big as the whole SVG. And we give it an ID. And then we use this clip path here on the text. And now it's fully scaled, so the text will be visible. This is our basic markup. And then we do the animation in JavaScript. So we get all the elements. We define some custom easings, some cubic Bezier easings, because these will feel more natural in the animation. They will be quicker or slower depending on if it's animating in or out. And then we're defining the duration for our whole animation. So we have a duration of 2 seconds. We make the basic easing as sign out. And we want it to iterate infinitively. And direction alternate is saying, well, animate it to this state and then go back again to the starting state. And then we call animation on each object. So the text clipping we want to animate first. So all we need to do is give it an array with keyframes. We want to go from 0% scale x0 to 100% scale x1. Here's a typo. And then the needle is animated differently. So on the needle, we're animating the opacity and the transform. What's important that if you animate multiple properties, all properties need to be in all keyframes. So you couldn't just skip this because you need to have each property in each keyframe. And here, I'm using the same duration as for the text. So I start the animation at 50%. So until 50%, it's not visible and not rotated, and at 50%, I'm actually starting the animation. And that's how it's synced with the other animation. So it's starting at 50% of the other text animation. And then I can define different easings on different keyframes. So here I'm defining an easing sign in to make it slow down towards the end. And that was what it looked like. So if you look at the needle, it kind of gets slower when it's like at the end position. What's interesting about the Web Animation API is that the animate object returns an animation object. So the function returns an object, and we can have control over our animation via this object. So I could, for example, add a click listener on my body and then increase the playback rate of this animation object my animation returned. I made a little example of this. So think about that it would be clicking all the time. So now it's just speeding up the animation whenever I'm clicking. So it makes it more dynamic, and I can control my animations with this animation objects. And it has different functions. So I can pause my animation, I can play my animation, I can cancel my animation, so make it go to the starting state. I can finish my animation, or I could reverse it, or I could increase the playback rate like we saw just now. And then the animation object also has callback functions like an onFinish function, which is really useful to play another animation once the previous animation is finished to kind of sequence different animations. And then I also have an onCancel function that calls a function when an animation is canceled to, for example, remove a DOM element because you don't need it because the animation has been canceled. Another thing I want to talk about is animation accessibility. So this is actually CSS, not the Web Animations API. But here we're looking at the prefer reduced motion media query. And what we can do with CSS variables is, for example, to define all my timings with a variable. And then if my user prefers reduced motion, I could just set the timing to 0, and then the animation would not play because they don't want any animations. And then with the Web Animation API, I can also look at the prefers reduced motion query, and then I could get all my animations. So we can have the document get animations. This gives me all my animations in my document. Also, I think the CSS animations. And then we can cancel all the animations to make them not run if they prefer reduced motion. And this is important because a lot of people don't want animation because they can get motion sick. And you shouldn't force animations on users. This is a big problem with, for example, parallax effects, where a lot of things move around a lot, and it makes users with sickness leave because they can't look at it. And why should you use it? Well, it's an API by the browser. There is no extra JavaScript like for big animation libraries. And you can render animations over the compositor thread. So you don't have any JavaScript stalling. So a lot of the animation libraries run over JavaScript. And if your JavaScript is stalling, your animations also won't run. And this doesn't happen with the Web Animations API. And it gives you more power than with just CSS animations, especially if you chain a lot of animations and have a lot of animation sequencing. It's very hard to read in just CSS because you have to write a lot of code. And it's easier with the Web Animations API. And the browser support is pretty good now. So it's even in the new Edge version now. It's in Firefox, Chrome, Safari. So it's in all the major browsers. And it's fine if you have IE to fall back to no animations. So kind of progressively enhance in the modern browsers and have no animations if the browser doesn't support it. The last part where animation is really useful is attention and feedback. There's a really good book by Rachel Neighbors that's called Animation at Work, which is kind of about practical web animation. And she says that feedback indicates causation between two or more events, often used to connect the user's interaction with the interface's reaction. What does this mean? Well, you can use animation to give a reaction to some user input, like clicking a button or filling out a form. You can show the cause and effect of a user's input. So if, for example, they entered something wrongly, you can show them, well, you did a mistake there. Maybe you should look again. And you could make system activity visible. So to show once they submitted a form that you're still processing it and that they should be waiting and not just leave. There's a good code bend by David Khurshid, and it's not working. Oh yeah. Which is kind of a password entry, then it's validating, it's showing you that it's validating. And then it's saying invalid password and like animating the color and having kind of like a very visible animation. And if it's correct, it has a different animation to show it's correct, which gives the user feedback and shows them, well, you've done something right or wrong. And then the second part is attention. You could show possible actions on a page. So with attention, you have to be careful because it can take something away from the user when he's trying to do something else. But you could use attention animation to show possible actions in your application. You could teach the user about a process, use animation to do storytelling, to show how a process works. Because that's easier, often showing with motion is easier than reading a long text. And then animation is also really good for reinforcing branding and just adding some fun. So maybe they've done a lot of things and then you show them a little fun animation to make it nicer to use. Stripe is really good at this. So they have a lot of these small interface animations in showing how it works. So for example, they have these animations for the different banks and checkout options you can use. Or here they have some different coding languages for the developers, and it animates in between, and it makes it more fun to stay on the site and to keep the attention of the user. So the last part and demo I want to show you is a reactive animation. And the reactive animation, there's a researcher called Connell Elliott, and he's saying a reactive animation is one involving discrete changes due to events. So in JavaScript, we have a lot of events we can listen to, and then due to those events, we can adapt some kind of animation to the user input. Kamal Elliott also has a really funny website with like GIFs that are spinning around. But what's interesting is that you can read all his papers, and the functional reactive animation was the one I was just talking about, which is from October 2007. So anyway, we can do reactive animation really well with JavaScript and CSS variables because it kind of like splits the events from what we're actually changing. And we can set a CSS variable in JavaScript by getting an element, calling the style, and then calling the set property function. And then we have first the variable name and then the variable value we want to set. And then we can apply any variable in CSS. So instead of setting the transform in our JavaScript, we're just setting the variable. And then we're applying the change to the element we want to change with the var keyword in CSS. And if you do animation, you have to be careful with setting CSS variables because they're always inherited from their parent. And if you set them in a global scope, all the child elements need to recalculate if you change something continuously. So for animation, you should set them at the most local specific level to decrease recalculation. So I found this card on the conference website, and that is what I animated. Does it work? Yeah. So we have this kind of 3D effect, and it's moving according to how the mouse is moved and translating according to how the mouse is moved. There's different parts to this on how to do it. So first we have this outer card, which I call .panel. It's the class. And we need to set the variables on this panel. I just chose to call the variables x and y, and I chose for the variables to be between -1 and 1, depending if the mouse is left or right or top or bottom. And then we have the different elements. And since the variables are inherited from the parent, all the different child elements will have access to those variables. And I just translate the x and the y of the elements. And this is what kind of gives it the parallax effect. And then for items I want to appear more in the front, I'm giving them a higher value of translation. So this will make them look like they're in front and not in the back. And then for the JavaScript part and calculating and reacting to the event, we need to get our panel element. We need to define some variables. And then we're listening for a mouse move event on our document. And here we're calculating our x and our y, which should be values from 1 to -1. So what we do is we take the event, the mouse event, the client x, which is a pixel value according to the window. We divide it through the window inner width, which gives us a value from 0 to 1. Then we subtract 0.5. So now we have a value from -0.5 to 0.5. And multiply it by 2, so we have a value from -1 to 1. And this is something we can really work with in CSS more easily than pixel values. And to improve the performance of our animation, we're calling the DOM updates, so setting the CSS variables inside a request animation frame function. So the request animation frame function is a function that runs DOM updates more performantly when a frame is ready. And then we have our update function that just sets the properties, the x and the y, and then resets the request animation frame so it can be called again when the calculations are done. For the rotation of the panel in the back, I used Matrix 3D because I thought it was interesting and I wanted to learn about the Matrix 3D. And if you've done computer graphics, they're not that easy to understand. But here, I'm using a calc with my variable and then multiplying it with a really low value. And this will kind of rotate my card, and I will show you why. And then I'm transitioning my transform here, so the card gets animated smoothly. So what is Matrix 3D, you say? Well, I haven't used it before, and I was kind of like, well, how do I use it? What do I change? Where do I put my variables? And then I found this tool by Eric Meyer, which is called the matrix resolutions tool. And what you can do in this tool is you add some CSS transforms, and it's kind of dark now, but it kind of like shows you the 3D changes here. And then here in the bottom, you can click the red pill, and then you can add some more things, but then you could also click the blue pill, and then you kind of want to try to click the blue pill, but then it's all gone and you need to type it again. And we want to rotate our card. So here is a rotate Y by 40 degrees, and we see already it's not rotating in a 3D space. And here are a little bit of understanding for the matrix 3D function. So it can do like rotate 3D, rotate X, rotate Y, translation, perspective. And depending on what you're trying to do, for example, if you want to rotate X, you would need to enter the cosine, the cos and the sine of the degree you want to rotate it. Or if you wanted to scale, you'd need to change these different values for scaling X, Y, and Z. And what we wanted to do is rotate our card according to the mouse input. So we just change this value here on top according to our variable on X and according to our variable on Y. So it will change it in the 3D space. And we could also have done this with rotate Y if we set a perspective on a parent. So this is a lot easier to read, but if you learn about matrix 3D, it can be quite useful to use with CSS variables. And if you don't have a perspective on the parent, it won't be rotated in a 3D space. And then the differences in the translation kind of created this 3D parallax effect where one element seemed more in the front or more in the back. And that's all that needed. So these are translated by 30 pixels. This is only translated by like 6 pixels. And the card is rotated with a matrix 3D or a rotate Y. Why are these so great? Well, JavaScript and CSS variables, they're easy to debug because you see your variables that are being set in the DOM. You don't have excessive DOM manipulation, so you just set the X and the Y variable on the parent and then use it in all your child elements without needing to set all transform on every child element. So they're kind of DOM node independent. They're great if you want to animate multiple child elements. And they're really great for reactive and physics animation because you're doing all your updates in JavaScript and then doing the different transforms in CSS. And also you can transform individual properties. In the beginning, we saw that we can chain different transform properties. And sometimes you only want to change the rotation, but not that translation. And instead of rewriting the whole thing, you can just use a variable to change that. The last part I want to talk to you about are animation principles, so the timing and the easing. There's a really good article by Val Head that's called How Fast Should Your UI Animations Be? And she talks about the different timings for animations. So for really small distances, hover effects, fading, scaling, shorter animation timings to up to 200 milliseconds are good. If you have really large movements on your page, maybe you should go more up to 500 milliseconds. The same for complex easings. So very complex easings, like bouncy easings, they take more time, so you should give them longer timings. And you already saw that I used some sine easings. There's a website called easings.net, and it has a lot of different CSS easings you can use and the copy to code. But then there's also easings that can be only done in JavaScript. Like these are more complex easings with more curves. So like elastic easing, bouncy easing. There's also examples for those on the website, but you can only do that in JavaScript. And if you're using GreenSock or GZEP, which is a very popular animations library, they have this ease visualizer to kind of show you, well, what's the difference between a ease in and the ease out and the timing, and you can kind of learn about the different easings and preview them. Ease out sign often feels more reactive and instantaneous because it starts quicker. So often, for example, for a hover effect, the ease out sign will be better than like a ease out in or a ease in, ease out. And very complicated easings need more time. So for elastic easing, just give it longer timings. And when an element is moving into the screen, it should probably get slower towards the end. So for moving something into the screen, it's better to use a ease out, so it gets slower to the end when it's into center. And then when it's moving out of the screen, it should probably start slower and then be quicker towards the end. So a ease in would be better. All right, that's most of it. To recap, some good opportunities for animation to use them in your applications that are actually useful are to make idle times more useful and interesting, to guide the user through a process and give him some more or show him some more information, to explain relationships between different information spaces or between different elements that are appearing or disappearing, and to get the user's attention if you really need it, to show him that he's done something wrong, for example. Here are some more resources you can look at. So the Animation at Work book by Rachel Neighbors is very useful for just learning about how animation works, how we process animation, how can you prioritize animation in your developer team. There is a Twitch channel by David Khurshid and Stephen Shaw. They live code lots of UI animations, which is very useful in just learning how to code animations. There's a Slack channel with lots of people who do web animation, also WebGL and Canvas and all kinds of things. There you can talk to a lot of the people that write blog posts and that are in the animation community. Developers, the Google developers also has some basics to know about animation, like the rendering I told you about. And there's also a newsletter by Wallhead, I think, that always sends out new animations that are useful. Before I leave, there's one really good quote by Heather Daggett that says, users should only notice your animation if you need to attract their attention in that moment. Otherwise, micro-interactions and other transitions should be so seamless that users don't even notice that there is animation. So very visible animations aren't often the best animations. A lot of good animations are not that noticeable and slowly transition between different things and make everything easier and nicer to use. So animate for the users, don't create obstacles. Think about people who have motion sickness through animations. Don't create obstacles. Thank you.